Mark August 12th on your calendar. On that single turn of the Earth, 4 separate astronomical events happen in the sky, and 3 of them are visible from almost anywhere on the planet. Astronomers are already calling it one of the single biggest skygazing days of the century. It doesn't matter if you're watching from the United States, Canada, India, or Europe. You don't need a telescope. You don't need to travel. You need a dark patch of ground in a few hours after midnight. Here's what makes it strange. During the day on August 12th, the moon slides directly in front of the sun and drops a shadow across the Arctic, Greenland, Iceland, and northern Spain. That's a total solar eclipse, and it's the first one to touch mainland Spain in more than a century, since 1905, and the first total eclipse Iceland has seen since the year 1433. But that eclipse is only possible because the moon is exactly new that day. And a new moon means something else entirely for the rest of us. It means that on the night of August 12th, going into the 13th, there's no moon in the sky at all, which is the same night the Perseid meteor shower hits its peak, the same night the core of the Milky Way stands high in a completely dark sky, and the same night that, just before dawn, 6 planets are strung across the sky at once. This is a day the whole planet gets something, and it deserves real advanced planning. To understand why this date matters so much, you need to understand one thing about the moon, and it's the thing that ties all of this together. The moon is the single biggest source of natural light pollution in the night sky. A full moon can wash out roughly 90% of what you'd otherwise see. Even a half moon raises the background glow enough to erase faint meteors and flatten the Milky Way into a smudge. This is why serious skywatchers don't plan around individual events. They plan around the moon. New moon is the one phase where the moon sits directly between us and the sun, lost in the daytime sky, contributing nothing to the darkness of the night. In 2026, new moon arrives at 1737 Universal Time on August 12th. Now look at what that timing collides with. The Perseids peak within a day of it. The galactic core is still riding high in the evening sky in mid-August. The pre-dawn planet lineup is near its tightest in that same window. Normally, you get one of these events under a dark sky and the others get washed out by moonlight. In 2026, they all land inside the same blackout. And because the moon is precisely geometrically new, it also crosses the sun's disk that same afternoon. The eclipse isn't a separate coincidence riding alongside the dark sky. The eclipse and the dark sky are the same underlying event, observed roughly 12 hours apart. A new moon won't fall on August 12th again until 2045. Start with the meteors, because this is the part almost everyone on the planet can actually see. Every August, Earth plows through a river of debris left behind by Comet 109P Swift-Tuttle, a comet roughly 16 miles across that last passed near the Sun back in 1992. The grains it shed are mostly the size of sand. They hit our atmosphere at roughly 37 miles per second and burn up around 60 miles overhead. That's what a Perseid actually is. Not a falling star, a speck of comet dust being destroyed by friction with the air. The shower runs from mid-July through late August, but the rates spike sharply around the peak. NASA and the American Meteor Society both describe conditions this year as optimum specifically because of the new moon coinciding with the peak. Under a genuinely dark, rural sky, expect somewhere in the range of 30 to 70 meteors an hour, with some forecasts suggesting up to 100 under exceptionally dark conditions. From a suburban backyard with some light pollution, expect considerably fewer, but even the lower end still typically works out to a meteor every few minutes. The predicted peak instant lands around 14:53 Universal Time on August 13th, meaning midnight through dawn on the 13th. Local time across most of the world is your best window. Here's an important detail worth knowing. The Perseids produce more fireballs than almost any other annual meteor shower. A fireball is a meteor brighter than Venus or Jupiter, bright enough to occasionally cast a faint shadow on the ground, and it often leaves a glowing train of ionized gas hanging in the air for 10 to 30 seconds afterward. In a normal year, moonlight steals those trains from view entirely. This year, nothing does. So how do you actually watch a meteor shower properly? Meteors appear to radiate from the direction of the constellation Perseus, which climbs into the northeast late in the evening and keeps rising until dawn. Don't stare directly at Perseus itself. Look about halfway up the sky in any general direction, and let your peripheral vision do the work, since meteors are often easier to catch out of the corner of your eye. Give your eyes a full 20 minutes to adapt to the darkness, and keep your phone off during that entire window, since even a quick glance at a bright screen resets your night vision back to zero. The best viewing window runs from your local midnight through first light, because after midnight, your side of the planet is turning to face directly into the debris stream. The Perseid radiant sits fairly far north in the sky, so this particular shower strongly favors the northern hemisphere. If you're watching from Australia, South Africa, or Argentina, you'll see meaningfully fewer meteors, and only during the hours before dawn specifically, which brings us to the part of the night where the southern hemisphere actually wins. While you're waiting for meteors, look south. The bright mottled band running across the sky in August isn't a cloud, and it isn't a nebula. You're looking edge-on through the disk of our own galaxy, toward its center, roughly 26,000 light-years away in the direction of the constellation Sagittarius. The dark lanes cutting through that band aren't gaps in the stars. They're clouds of interstellar dust blocking the light of stars behind them. Most people alive today have genuinely never seen this. Roughly a third of humanity currently lives under skies too bright to show it at all. Seeing it properly takes two things: real distance from city lights and no moon in the sky. August 12th gives you the second one for free. Timing matters here too. The galactic core is already well up as twilight ends in mid-August, sits roughly due south around mid-evening for northern mid-latitudes, and starts sinking after that point. Get outside earlier rather than later for this specific part of the night, then stay out for the meteors afterward. If you're in the southern hemisphere, the galactic core passes far higher in the sky, close to directly overhead, which is part of why the best Milky Way photographs on the planet consistently come out of places like Chile, Namibia, and New Zealand. There's a real deadline attached to this particular window too. This is the last new moon of the year that catches the galactic core riding high in a properly dark sky right after twilight ends, as seen from northern latitudes. By September, the core is already low in the southwest and setting early in the evening. By October, it's effectively gone from the evening sky until spring returns. Now stay outside until the sky actually starts to lighten, because the final act of the night is arguably the strangest. In the roughly 90 minutes before sunrise on August 12th, 6 planets are spread across the sky simultaneously: Neptune, Saturn, Uranus, Mars, Mercury, and Jupiter, arranged running from the southwest down toward the eastern horizon. Set your expectations correctly here, because 4 of these are naked eye objects and 2 genuinely are not. Saturn is the easy one, sitting high in the south, unmistakably steady in brightness and clearly yellow in color, distinguishing it immediately from any twinkling star nearby. Mars sits lower in the east among the stars of Taurus, gradually moving toward Gemini as the month progresses, and it's genuinely faint right now since Mars doesn't reach its next opposition, its closest and brightest approach to Earth, until February 19th, 2027. It will brighten steadily from this point forward. Uranus requires binoculars to spot reliably. Neptune requires an actual telescope. The harder part of this planetary lineup sits at the bottom, closest to the horizon. Mercury and Jupiter sit lowest in the sky, closest to the coming sunrise, and the window during which both remain above the horizon while the sky is still dark enough to see them is genuinely short, often under 30 minutes, depending on your location. You need a flat, open eastern horizon with no buildings or trees blocking your view, and you need to be in position earlier than you probably think you need to be. Each of these 2 planets is doing something specific astronomically right now. Mercury reached its greatest angular separation from the Sun in the morning sky at the very start of August, and is now falling back sunward, heading toward what's called superior conjunction, passing behind the Sun from our perspective, on August 27th. It's genuinely on its way out of easy visibility. Jupiter is doing precisely the opposite. It passed behind the Sun in late July and is now climbing back into view, beginning a fresh viewing period that will carry it through the remainder of the year. Because one planet is falling sunward while the other is rising away from it, their paths cross. On the morning of August 15th specifically, Mercury and Jupiter pass close together, low in the east before sunrise. Both are genuinely bright, near magnitude -1, and the pairing is visually tight. It's a difficult catch, given how close to twilight it happens, but if you have a clear horizon for it, it's arguably the prettiest single sight in the sky that particular morning. You'll likely notice one planet conspicuously missing from that pre-dawn lineup. Venus isn't part of the parade, and that's not bad luck. It's simply because Venus is having an excellent month on the opposite side of the sky entirely. It reaches its greatest eastern elongation on August 15th. Its farthest apparent distance from the Sun is seen in the evening sky at nearly 46 degrees, shining at roughly magnitude -4.4. In the west after sunset, nothing else in the sky comes remotely close to matching it in brightness. Then the moon itself returns to visit Venus directly. On August 15th, a thin crescent moon sits just below Venus with earthshine, sunlight reflected off Earth itself, faintly illuminating the moon's dark side. On the 16th, the moon slides directly between Venus and Spica, the brightest star in the constellation Virgo. On the 17th, it moves on past Spica entirely. These 3 consecutive evenings offer one continuous piece of celestial motion you can watch unfold with nothing more than your own eyes across a few nights in a row. Now back to the eclipse itself, since it's the anchor event around which everything else on August 12th orbits. The moon's shadow touches down at sunrise in a remote part of northern Siberia, then sweeps up and nearly grazes the North Pole, missing it by roughly 100 kilometers, before curving south across Greenland's eastern coast. From there, the shadow crosses western Iceland, including the capital Reykjavik, which sits inside the path with about a minute of totality, beginning around 5:48 in the evening local time. The absolute maximum duration of totality anywhere along the entire path is 2 minutes and 18 seconds, occurring just off Iceland's western coast. The shadow then races across the Atlantic at roughly 2,100 miles an hour and makes its final landfall over northern and eastern Spain in the early evening, with a small corner of northwestern Portugal also falling inside the path. Bilbao, Zaragoza, Valencia, and the island of Majorca all sit inside the path of totality. Madrid and Barcelona sit right on the edge, narrowly missing full totality, with roughly 9% of the sun covered instead. Even for people nowhere near that narrow path, a large part of the world still sees a partial eclipse, where the moon covers only a fraction of the sun's disk, and the closer you are geographically to the actual path, the bigger that fraction becomes. Across the United Kingdom and Ireland, this plays out as a genuinely deep partial eclipse low in the evening sky, generally 90% or more of the sun covered. Dublin reaches roughly 94% coverage, one of the deepest partial views anywhere outside the path itself. Across the rest of Europe, Paris reaches around 92%, Lisbon about 94%, and Oslo around 83%, most of it occurring close to local sunset. For North America, this plays out as an afternoon event, and no part of the continent sees full totality. In Canada, the Far East gets the deepest coverage, with parts of Newfoundland reaching over 50%, tapering down considerably as you move west, with Montreal seeing around 18%. In the United States, the deepest coverage falls across far northern Maine, with visible partial eclipses extending in diminishing amounts as far south as North Carolina, and Alaska catching its own separate morning version, with Anchorage reaching close to 30% coverage. Wherever you happen to be, if any sliver of the sun remains visible, certified eclipse glasses need to stay on for the entire duration. Regular sunglasses are never sufficient protection, and looking at even a thin crescent of exposed sun without proper filtering can cause permanent eye damage. The August 12th eclipse can't actually happen in isolation, astronomically speaking. Eclipses come in pairs or occasionally triplets, because the precise alignment that lets a new moon fully cover the sun tends to hold for roughly a month at a time, not just a single day. So the very next full moon, a couple of weeks later, walks directly into Earth's own shadow instead. On the night of August 27th into the 28th, a deep partial lunar eclipse takes place. At maximum, roughly 93% of the moon's visible diameter sits inside Earth's shadow. The moon passes just north of the shadow's exact center, meaning its southern half goes considerably darker, while a thin strip along its northern edge stays in direct, unshadowed sunlight the entire time. Geography decides almost everything about who actually gets to see this one well. The Americas get the best view, with the moon riding high throughout the entire event. For North America specifically, this unfolds on the evening of Thursday, August 27th, with maximum eclipse occurring just after midnight Eastern Time. Western Europe and Western Africa catch a lower, more limited view, with the moon setting while the eclipse is still partially underway. Most of Asia, including India and effectively all of Australia, miss this particular lunar eclipse entirely, since the moon simply sits below their horizon for the entire event. It's worth understanding a bit more about why solar eclipses and meteor showers landing on the exact same night is genuinely rare, rather than a routine coincidence that happens every few years. A total solar eclipse can only occur during a new moon, since that's the only lunar phase where the moon sits directly between Earth and the sun in the sky. But new moons happen every month, roughly every 29.5 days. And the vast majority of them produce no eclipse at all, because the moon's orbit is tilted slightly relative to Earth's orbit around the sun. Most months, the new moon passes slightly above or below the sun from our vantage point rather than directly in front of it. An actual eclipse requires the new moon to occur very close to one of the 2 points where the moon's tilted orbital path crosses Earth's orbital plane, points astronomers call the lunar nodes. That geometric requirement is precise enough that total solar eclipses touching any specific populated region of the globe are genuinely uncommon events, often separated by decades, for any given stretch of coastline or country. Layer onto that the additional, entirely separate requirement that a major annual meteor shower's predicted peak also falls within roughly a day of that same new moon, and you get the kind of alignment that astronomers are right to describe as one of the more remarkable single nights of the current century, not through any exaggeration, but simply because the underlying orbital mechanics genuinely don't line up this cleanly very often. It's also worth explaining a little more about why the far northern path of this particular eclipse looks so different from the straighter, more predictable paths many previous solar eclipses have traced across the globe. The shape of a total solar eclipse's path depends heavily on where on Earth the moon's shadow happens to fall relative to the planet's curvature and rotation. This particular eclipse's path grazes extremely close to the North Pole itself, missing it by only about 100 kilometers, which produces a noticeably curved, almost looping trajectory across the map, rather than the more familiar diagonal line eclipses typically traced through mid-latitude regions. That polar proximity also explains why totality duration varies so significantly along the path, starting relatively short in far northern Siberia, stretching to its maximum of 2 minutes and 18 seconds off Iceland's coast, and then gradually shortening again as the shadow races southeast towards Spain and Portugal by evening. Anyone chasing totality specifically should understand that even a shift of a few kilometers from the exact centerline of the path can meaningfully change how long totality actually lasts at their specific viewing location, which is why serious eclipse chasers typically consult detailed interactive path maps rather than relying on city-level generalizations alone. There's also a practical weather dimension worth factoring into any serious eclipse viewing plans, particularly for anyone considering travel specifically to catch totality in Spain. Wildfire activity has been a recurring feature of Iberian summers in recent years, and smoke from active fires anywhere near the eclipse path has the potential to significantly reduce visibility of the eclipsed sun, even in locations that would otherwise have clear, cloud-free skies. That's a genuinely unpredictable variable this far in advance, and it's part of why experienced eclipse chasers generally recommend staying mobile rather than committing to a single, fixed viewing location booked months ahead of time. A gambler's approach, keeping transportation flexible enough to relocate a short distance at the last minute based on updated cloud and smoke forecasts, tends to produce meaningfully better outcomes than locking into one hotel reservation and hoping the sky cooperates on the day itself. For anyone specifically interested in photographing this night rather than simply observing it, a few practical notes are worth keeping in mind. The eclipse and the meteor shower demand almost entirely different equipment and techniques, and trying to capture both perfectly with a single camera setup running simultaneously is genuinely difficult. Eclipse photography requires a proper solar filter on the front of any lens or telescope used before totality begins, removed only during the brief window of totality itself, and precise timing since totality lasts mere minutes at most locations along the path. Meteor photography works completely differently, typically involving a wide-angle lens, a stable tripod, and a long sequence of consecutive exposures, often 15 to 30 seconds each, run continuously over several hours so that individual meteor streaks can later be layered together against a single clean background image of the sky. Attempting both in the same evening generally means either dedicating separate cameras to each task or accepting that one will get considerably more attention and effort than the other depending on your specific location and priorities that night. It's genuinely worth remembering, especially for anyone who has never deliberately traveled to see a natural sky event before, that total solar eclipses in particular tend to produce a reaction in people that photographs and video never quite capture. The temperature perceptibly drops in the minutes leading up to totality. Birds and other animals often visibly change their behavior, sometimes falling silent, sometimes beginning what looks like an evening routine hours ahead of schedule. The sky doesn't simply dim the way it does at dusk. It takes on a genuinely strange, artificial-looking twilight in every direction at once, since you're standing inside a shadow racing across the Earth's surface rather than simply watching the sun set in the normal way. Then, for the specific duration of totality, the sun's outer atmosphere, its corona, becomes visible directly around the black disk of the moon, a pale, wispy halo that's normally completely invisible, washed out by the overwhelming brightness of the sun's surface itself. That corona is genuinely only visible to the naked eye during totality, nowhere else, at no other time, which is a significant part of why scientists treat these brief windows as genuinely valuable, rare opportunities to study the sun's outer layers using ground-based instruments rather than relying purely on space-based observatories. Whichever specific piece of this night you end up chasing, the total eclipse itself if you can reach the path, the deep partial eclipse if you're somewhere in Europe or eastern North America, the Perseids and the Milky Way if you have any reasonably dark sky available locally, or simply the pre-dawn planetary lineup from your own backyard. August 12th represents a genuinely unusual convergence that won't repeat in quite the same combination again for a very long time. The specific pairing of a new moon, a total solar eclipse, and the Perseid peak landing within roughly 12 hours of each other is not something anyone currently alive is likely to see line up this precisely again without a very long wait. And that scarcity alone is worth treating this particular date with more advanced planning than a typical summer sky event usually receives. A new moon landing this precisely on top of both a total solar eclipse and the single most reliable meteor shower of the year won't happen again until 2045. Which means for most people currently making plans for August 12th, this is genuinely a once-in-a-generation opportunity rather than simply another item on an annual Skywatching calendar. And it's the kind of night worth actually clearing your schedule for well ahead of time, rather than deciding at the last minute whether it's worth stepping outside. Pick your viewing spot now, not on the day itself, and pick somewhere genuinely away from city lights if you're aiming for the meteors, or the Milky Way specifically. Get outside at dusk on August 12th if you want the Milky Way core at its highest and clearest. Stay through the small hours of the night for the Perseids themselves, with the best window running from local midnight through dawn. Hold on until the sky actually begins to lighten if you want any chance at that difficult pre-dawn 6-planet lineup, particularly the tight, low pairing of Mercury and Jupiter. Then set separate reminders for the mornings around the 15th for that same Mercury-Jupiter conjunction, the evenings of the 15th through the 17th for the moon's visible path past Venus and Spica, and the night of the 27th into the 28th for the partial lunar eclipse if you happen to live somewhere in the Americas, Western Europe, or Western Africa, where it's actually visible. The sky is putting an unusually large amount on the table all at once this particular month, and the only real requirement it asks of anyone in return is that you actually go outside and look up.